Hello everyone, welcome back to IPEC by Sounish. So today this is the solution video of the problem from electrostatics that I have uploaded a few days ago on this channel. So if you haven't watched that problem yet, you can check it out from the description box of this video, or you can click on the I button also. So today I'm going to discuss this problem, and I will use here two methods. So the first method is a very good method, and the second one is a very quick approach. So let's see the solution. So I have to calculate the electric field at this point. So for this I will break this system into two parts. First I will calculate the field here, and then I will subtract the field here because of this small tetrahedron. Now in this method we will assume the electric field. So here I have assumed that the electric field at a corner of a tetrahedron will be like this, arbitrary constant, say beta, times q, that is the charge in this tetrahedron, upon L square, distance length square. Okay, I will assume like that. And where did I get this hint to assume like that? That is the general formula for electric field, kq upon r square. From there I have got the hint to assume like this, that it will be something arbitrary constant times charge upon L square. And it is given in the question that the value of this field is E. It is already given in the question. Now, as the structure is looking similar, we can say that the field at this point of this smaller tetrahedron will also look similar to this. The beta constant will be also same here. So the field at this point due to this smaller tetrahedron is beta times charge upon length square. Now what is the charge on this? So we have to first calculate that, and the length is obvious that it is already given in the question that this has half of the length of this bigger tetrahedron, so the length will be L upon 2. But what will be the charge? So for this calculation of charge, we have to see that how many such tetrahedron segments are there in this bigger tetrahedron. If that is an integer, then we can calculate it easily. So we have to first calculate that. So for that I have assumed the formula for of volume for this tetrahedron, because I don't know the actual formula. I have assumed it that it will be something constant alpha times length cube. That will be the formula for this bigger tetrahedron. And the formula for this smaller tetrahedron, that will be also be same, and it will be alpha times L upon 2 cube. Now we have to see that is there any integer number for their volume, like I mean if this volume consists of such parts. So let's see, I assume that the volume of the bigger one is n times the volume of the smaller one. Now what I did is I divided them v upon v dash, and that is the value of the n, and calculating it I get it to be 8. That's mean there are 8 such small tetrahedrons which will make this bigger tetrahedron. And as the charge is uniformly distributed. It is already mentioned in the question that the charge is uniformly distributed. So I can say that in every such smaller tetrahedron there will be a charge of q upon 8. As there are 8 tetrahedrons, so every tetrahedron will have charge in its volume of the value q upon 8. So now it is easy, I have already calculated the length. So it became beta times q upon L square times half. Now beta times q upon L square, this is E. So the field value at this point P for this smaller tetrahedron become E upon 2. So now subtract them. So by subtracting them we get E upon 2. So that is the answer. So this is a very good approach for this problem, and I think all of you have seen this type of approach in several problems. Now there is a very quick approach for this problem, and that type of approach are very useful in JEE advanced problems. Sometimes JEE asks you such questions where you will get nothing, no thought process, and then you will suddenly have the thought of dimensional analysis. Yes, so our second method is dimensional analysis, and that this is a very good approach, and JEE sometimes ask questions on this and students get confused with that bigger questions, such big sentence, and they got confused and they messed up. So this is we can do it also by dimensional analysis. So from dimensional analysis we can say that the electric field at this vertex will be a constant times charge upon length or distance square. Okay, now what is charge? Charge is simply volume charge density multiplied by the volume of the structure. Now as it is already mentioned in the question that the charge is uniformly distributed, so we can say that this rho is also a constant value. So if I put surface charge density time volume here instead of this charge, then that rho value will also get merged up in this constant value. So I am left with only this volume term. Now what is volume? It is length cube or distance cube. So my electric field dimensionally became a constant times distance cube upon distance square, which is simply distance. So finally I get this, that my electric field is a constant times length dimensionally. So from here we can say that when my length is A, the field at P is E. When my length is A upon 2, my field will also be E upon 2. This is simple, and then you subtract them and you get E upon 2. So this approach is a very good approach, and JEE asks big problems on this several times. So hope you have enjoyed this problem and its solution. If you have any question, then you can drop it in the comment box. I'll be there to help you. And if you are new to this channel, make sure that you subscribe to this channel, because I upload problems and solution to physics regularly in this channel. So make sure that you subscribe this channel and hit this like button and share this video with your friends who are interested in physics problems. So thank you. I'll be back with another amazing problem video soon. So see you in the next video. Take care. Tata. Bye bye.